Let us now study how LC circuit will produce waves. That is LC wave, that is the oscillations there. That is generation of LC oscillations. Okay. So inductor, capacitor, that is LC. So I have drawn this way. This is an inductor and this is a capacitor. Okay, the same picture I have drawn different times. Okay. The process we are going to see in different times there. So that's why we drawn some pictures here. So first let's take this picture here. Okay. So we have a capacitor and an inductor. Okay, that's a LC circuit here. Now in this circuit, first what we do, we'll take the, imagine that the capacitor is fully charged first. Okay, so we have 4 positive charges, 1, 2, 3, 4, 4 positive charges on the side plate, and the negative plate we have 4 negative charges here. Okay, 4 positive and 4 negative. Okay, so what happens, all the energy is stored in the form of the electrical energy only. Okay, so we can say, we can draw a graph for energy and for magnetic field. Okay, we learned now energy in a capacitor is stored in the form of electrical energy. Okay, so the graph, if you see, all the energy is fully electrical only. So UE, okay, and the magnetic energy is 0. Okay, there's no energy in the magnetic field. Okay, so magnetic energy is 0. So all the energy is fully stored in the electric field only. Okay, you can share this also. Okay, so entire energy is in the form of electrical energy. So we can say the capacitor has full of electrical energy. So we can say wholly electrical energy. Okay. Electrical energy. Okay. So imagine the first charge, capacitor has full charge now. Okay, the value of full charge we can say that is Qm. Qm is the value of the full charge, and the energy stored in that case will be UE is equal to Qm square divided by 2C. Okay, 2C. Okay, Qm means a full charge here. Capacitor has full charge. Okay, the charge in the capacitor is full charge here. That is Qm. I'll write here the side. Okay, let me rub it out. So next what happens is, we will see the second part here. Okay, what happens there? We're going in the clockwise direction like this way. Okay, this is the second picture here. So in the second picture, what happens is, now the capacitor has positive charges now. Okay, some of the positive charges will be decreasing and the current will flow like this way. Okay, so this is capacitor plates here. Okay, first the capacitor has 4 positive charges. Now it will have 2 positive charges here. Okay, why? Because the current I will start flowing here. Current I flows like this way in the clockwise direction. Okay, in this coil here. So when current is flowing in the coil will produce a magnetic field here. We know that. Okay, coil produces a magnetic field. Okay, this is a magnetic field here, and the current will come this direction also. Current flows clockwise. Okay, now if you see, both there is and this side we have 2 negative charges here. Okay, so we have electrostatic energy and magnetic energy also. It's be equal. Okay, so for the graph, how to draw? Okay, so we have half electrical energy and half magnetic energy also there. Okay, this half is electrical energy, this half is magnetic energy. So electrical energy we write as UE and the magnetic energy we write as UB. Okay, both are equal. Okay, next we'll see in this part here, third picture, that is C picture, what happens. Okay, now the capacitor is giving the charges here. Okay, afterwards all the charges will get over now. Okay, so the capacitor will have 0 charge here. Okay, and all the energy will be stored in the form of magnetic field only. Okay, so the capacitor, the inductor will produce all the magnetic field. So in this case we have wholly magnetic energy. Okay, wholly, that means fully magnetic energy. Okay, entirely we have magnetic energy. Okay, so in this case what happens is, but current will be flowing here now, and this time we'll have the maximum current here. That current will be I, capital IM. That's a maximum current. Okay, so let us see now how to draw a graph for this thing. Okay, electrical energy, that will be UE is 0. Okay, and the magnetic energy, that is UB, will be the maximum in this case here. Okay, we have full magnetic energy only. Okay, this is a graph here. Okay, this is nothing different. This is a graph to show that. Okay, next we see what happens here. Okay, so inductor will have the magnetic field here. Okay, so this has no charge. Okay, this has a magnetic field. Now what happens? The magnetic field will collapse. Okay, it will decrease. Okay, as it decreases, okay, the current, the charge will be the magnetic field will produce a current in the opposite direction. Okay, and in this capacitor, if you see, this is a capacitor here now. Okay, we have the capacitor charge in opposite way. That is, this side will have minus charge here. Okay, first it was positive charge, now it will have the negative charge, and this side will become positive because this current will be still flowing here. Okay, the current will be I here. Okay, so actually the direction of current will be in the opposite direction. Okay, so it will have 2 minus charges this side and this will have 2 positive charges. Okay, because why? The magnetic field will decrease. Very, very important here. Okay, this is L means the inductor, okay, or the coil, and then this is the magnetic field decreases in this case here. Okay, that's fine. Next we'll see this picture here. This is all coming in arrows only. Okay, we'll draw arrows. Okay. Next we'll see this picture here, E picture. Okay, what happens in this case here? Now after some time, all the magnetic field will be gone. Okay, and the current here will be equal to 0. Okay, in this time what happens is the capacitor is there now. It will be opposite charge. It was negative charges to now. Now it will have 4 negative charges here. Okay, 1, 2, 3, 4. Okay, and then this will have 4 positive charges. 1, 2, 3, 4. 4 positive charges. Okay, you see the capacitor is now charged in the reverse polarity. Starting we had top positive, but now we have top negative. Okay, so it is just changed here. Okay, reversed. Now let's see the graph for that. Or before that, let's see for graph for this one. Okay, for D we didn't draw the graph now. Okay, we had fully magnetic energy now. Oh, okay, no, not fully. Half magnetic, half inductive. Okay, or the coil energy. That is UE and then UB. It will be half of that. Okay. Next we'll see this part here. Okay. In this case, the current is flowing in the circuit will be 0. The capacitor is fully charged. Okay, and we have fully electrical energy only. Okay, so graph for that will be like this way. Okay. That is UE. All electrical energy is stored in the form of electrical energy only. Okay, and the magnetic energy is 0. UB is 0. Okay, so now we have fully, or in this case, for this one I'm writing. Okay, wholly electrical energy. Electrical energy. Okay. Next we'll see for this picture here, F. Okay, what happens here? See for F picture, what happens is this capacitor has negative charge, 4 negative charges now. Now the negative charge will decrease, start decreasing. Okay, so again this will have one negative charge here, one negative charge here. Okay, one positive and one positive charge here. Okay, so what happens is current will flow now in the reverse direction. Okay, current flows from positive to negative. So current I will be flowing like this way. Okay, from this side to that side. And when current flows in the coil, we have a magnetic field produced here. Okay, now what happens is we'll have half magnetic and half electric energy. Okay, so that's why we graph, you see you can have two graphs like this way or two bars like this way. This will be the electrical energy and this is the magnetic energy, half of electrical energy, half of magnetic energy. Okay, now let's see the next picture here in this case here. Okay, in this case if you see, now capacitor for this one had 2 negative charges now. Okay, now there will be 0 negative charges. All the charges will be going here. Okay, it will be fully of this magnetic energy only. Okay, so in this case we have wholly magnetic energy like this way, just reverse of this. Okay, wholly magnetic energy, and the current flowing in this case will be IM. Okay, and wholly magnetic energy, full magnetic energy is there. For that, the equation will be UB is equal to LI square divided by 2. Okay, so like this way it is. Next we see for this picture here. Okay, now okay, graph for that. Now graph you must draw. Okay, so there is 0 graph. I'll draw here a little bit up. So 0 electrical energy and wholly magnetic energy. Okay, like this way. So entirely we have magnetic energy only. Okay, in this case here. Next we'll go to this picture here. Okay, in this picture let's see what happens here. Okay, now again the magnetic field will collapse. Okay, and then if you see, this capacitor will be charged reverse. Okay, so this part will have positive charges, 2 positive charges, and this will have 2 negative charges here. Okay, so and the current flowing, okay, will be in this direction here. Okay, so and magnetic field will be there. Okay, magnetic field will collapse again. It will be keep on collapsing and current will flow this side. Then last we see it will again go to A. It's like a cycle only. Okay, so last what happens is, and all the magnetic energy will collapse. Okay, and then we'll have 4 positive charges on this capacitor and 4 negative charges on this negative plate here. So graph for H, okay, for this picture, see it is half electric and half magnetic. So half electric, that is, and then half magnetic. Both the graphs will be equal. Electrical energy UE and magnetic energy UB. So this is the way the oscillations are produced in this circuit here, LC circuit. Okay, So you must know how each term goes. Okay, from this side to this one, what happens in each part here. Okay, so see the graph here, and then draw and practice this. Okay, so step by step if you go, it's easy. Okay, we can't draw everything at one time. Okay, you must understand this. What happens? The charges will be decreasing. Okay, as charges decrease, the magnetic field will increase. Okay, and in this case, what happens here? Full magnetic field is that the magnetic field collapse. Okay, so capacitor is charged reversely. Okay, then magnetic field is 0 here in this case. The capacitor negatively charged. Okay, then what happens here? Okay, again the capacitor will give a charge here this side. Current will flow in the circuit. Magnetic field increase. Okay, then you have full magnetic field here. This side what happens here? Half magnetic and half electric fields are there. Okay, then all the magnetic field collapse here, and then fully we have electric fields, electrostatic fields. Okay, not electric, electrostatic field will be there. Okay, so we have electrostatic field and magnetic field will be alternating. So let's see how the wave will be. Okay, let's see the theoretical wave. The theoretical LC wave will be like this way. It will have equal amplitudes. Okay, the amplitude will not change. But in real life, we have damped oscillations. Okay, we'll learn 11th also. So because of the resistance, the LC circuit will have some resistance, and because of the resistance, what happens? The oscillations will, the amplitude will be decreasing, and finally it will stop. Okay, so the energy will not, the oscillation will not be keep on going. Okay, the LC circuit will have a resistance, and due to heat energy and other various losses. Okay, and one more thing. You see, this is the LC circuit now. Okay, this was the LC circuit here. Okay, this is a coil here. Okay, it will also produce a wave outside. Okay, and there's a loss of energy. Okay, the radial wave will go outside. Okay, due to that, the energy will be lost here, and the waves will stop after some time. This is called damped oscillations. Okay, this is what happens in real life. Okay, thank you for watching.